Ladies and gentlemen, we're moving on to 7.3, something new called logarithms. 7.3. Listen up. Focus. We know that 2 squared equals 4. And we know that 2 to the third equals 8. And if I were to ask you 2 to what power will give you 16, the answer is 4. We already know that, right? We could do logic. And the setup for 2 to what power equals 16 is this. 2 to what power gives you 16. And we've been solving these kinds of equations, right? We've been solving these kinds of equations. These are exponential equations. And we solve this, you could solve this using mental math. I mean, technically, using the last section skills, you could change that 16 to become a 2 to the fourth. And you have 2 to the x equals 2 to the fourth. The bases eliminate, the x and the equals 4 comes down. But what if I asked you 2 to what power gives you 6? It doesn't work, right? 2 to the second is 4, 2 to the third is 8. So 2 to what power gives you 6? It must be between 2 and 3, right? 2 point something. So mental math doesn't work anymore. And we need logs and calculators, of course. Logs. Yes, logs. Now, it's really not that bad if you pay attention right now. If you don't pay attention right now, you're going to hate it even more. But if you pay attention right now, you're going to be like, hey, I got this. This is easy. All right? So, listen to this. Let's begin with the key concept. If you have a highlighter, it's a good time to take it out. If not, just go ahead and box this in right here. Key concept is log base. Well, first of all, let me tell you how to read it, all right? You don't just say log and then these letters. When you're talking about this little number, you got to say the word base right before it. Okay, so you're going to say log base b, and whenever you say this number right here, you got to say of whatever this is, all right? Log base b of y, and of course equals x. So do you understand how we're going to be reading these things? You have to use the word base before saying whatever's here. Okay, so if you have a 3 right here, you're going to say log base 3. If you have a 7, log base 7, right? So you got to use the word base right before you say this little number that's on the log. And before you say this term, you have to use the word of, all right? So log base b of y equals x. Again, log base b of y equals x. Now, this is what we call logarithmic form, and we need to be able to switch it, change it to exponential form, okay? Now, what is exponential form? It's b to the x equals y. So it's really just a question of rearranging things. This b, the base on the logarithm, is going to become the base on your exponent situation, okay? This y, the of y, actually becomes the answer over here, and the answer over here becomes the exponent right there. So let me tell you how this actually works out with actual numbers. I don't do this till later on the paper, but let me just do this right now. Log, let's say base 2 of 8 equals what? Now, if we understand this, the base on the logarithm will be the base on your exponent situation. So it's really, this 2 right here is really going to be the base of the exponent situation. Okay, and the exponent is going to be the answer that's over here. And the 8 that's right here is going to be the answer that we want down here in the exponent situation. So the answer is 3, okay? So when I say log base 2 of 8, the answer is 3. Why? Because 2 to the third power equals 8, okay? So that's what, whoa, that's weird. Let me get this out of the way. That's what this is doing right here. This key concept right here, it's just a question of rearranging the order, right? Log base b of y, that base on the log is going to become the base on your exponent situation. So you're really going to be thinking, this base to what power gives me this answer y? This base to what power gives me this answer y? And that's exactly what it says over here. This base to what power gives me the answer y? So it's just a question of rearranging. So we got to get used to practicing that rearrangement. In other words, rewriting from logarithmic form to exponential form, or exponential form back to logarithmic form. But before we get to that practice, let's show you the calculators. Anybody have a Casio? Or that one? Let me see that one. So it doesn't matter what kind of calculator you have or what color they are. Thank you, ladies, for letting me borrow your calculators. But there's a log button somewhere right here on the Texas Instrument. It's right there. It's log. And it's not, see how there's nothing down here? So it doesn't really have log base 2 or log base 3. These type of calculators only do base 10. And those are called common logs, okay? So right here, this log button is really log base 10, even though it doesn't say base 10. That's the only type of log that it does. It's called a common log. Same thing over here on the Casio. If you look for the log, it's right here. And again, that's the common log button, which means base 10. I'll get this out of the way. So common logs are base 10. So if you do not see a base on the log, you assume that it's base 10. Kind of like if you have an X and you don't see a number in front of X, you assume that it's a 1, right? So if you see a log with no base, you automatically assume that that base is 10, and we call those base 10 logs common logs. Now, there's also natural logs, right? What's a natural log? A natural log is a logarithm with the base e. So on our calculators, there's an E button. It's right there. You have to hit shift and it'll show that E button. The E button is a crazy irrational decimal, kind of like pi. Where's E? Here it is. The E button. So a natural log is log base E. Now, let me give you an example of each. So here's, let's say, log 100. So what does that really mean? That's a common log of 100. What base do we have here?
10.
Log base 10. If I don't show you a base, you automatically assume it's base 10. Now, knowing how to rearrange things, the exponential form, would you be able to tell me this answer?
Seconds.
The answer is 2. Why is that? Because 10 to the second power will give me this answer 100. Pretty cool, right? All right, an example of natural log. Now, this is weird. A natural log is an ln, the ln button. I don't know why they put natural log being ln instead of nl, right? Natural log, it probably would have been better with nl. But that's how they use, that's the button ln. And ln is really log base e, all right? Log base e. All right, so those are the two types of logs. Let's go to these examples down here of rewriting logarithmic form to exponential form. So if you understood the above key concept notes, you should be able to understand how to rewrite it in exponential form. See, log base 2 of 8 equals 3. Why? Because 2 to the power of 3 gives you this answer 8. That reasoning right there is the exponential form of this logarithmic form. Okay, so we need to take a logarithmic form equation and rewrite it in exponential form, and we also need to be able to take an exponential form and rewrite it back into logarithmic form. So again, the understanding or the main, what can I say, the advice I give you is remember that the base on the logarithm is going to be the base on your exponent situation. So right here, the base is 4. Log base 4 of 16 equals 2. So if I didn't give you this answer 2, what I would be asking you is 4, the base 4 to what power gives you the answer 16? Oh, the answer is 2. But right here, we're just practicing rewriting from logarithmic form to exponential form, right? Later on, we're actually going to be evaluating these guys. This is a common log right here. This is a good one. Log base 5 of 1 equals 0. Why is that? Because 5 to the 0 power equals 1. 5 to the 0 power equals 1. Log base 10 of 10 equals 1. Why is that? Because the base 10 to what power will give you the answer 10? 10 to the 1 power will give you 10. Does that make sense? And you know what? This right here brings up something very important. The log base 10 of 10, that kind of eliminates itself. The answer is 1. It's kind of like saying 3 divided by 3. It eliminates, it becomes 1, right? Or a plus 3 becoming undone with a minus 3. And I might as well throw this at you right now. Whenever you do have, let's say, log base happy face of happy face, that will eliminate. It'll become 1. You guys understand that? Mm-hmm. Okay, it's kind of like dividing 3 divided by 3. It eliminates, it becomes 1, right, on a fraction. With whatever. Log base anything of that same something, it eliminates, okay? So that's why right here, log base 10 of 10 equals 1. I mean, the actual mathematical reasoning would be 10 to the power of 1 equals 10. But that's something very important that we're going to have to deal with in the future. Right here, the base to what power gives you y? That base to what power gives you y? Now, this is why when I ask you to evaluate log base 8 of 64, the answer is 2. Why is that? Because 8 squared equals 64. So if I do give you this problem, log base 8 of 64, what you should do or should remember is that that base on the logarithm is going to be the base of your exponent. And you're really thinking 8 to what power gives you 64? Well, 8 squared gives you 64. Cool? All right. So at this point, I would like to turn the paper over right now. And we have some practice problems right there. So right here, these problems right here are going to be similar to the ones that you're doing on questions 13 through 18 on the homework. We're actually going to have an assignment. You'll have time in class to do it, but if you don't finish, you can do it at home. Number 1, log base 8 of 64 equals 2. I need to rewrite this in exponential form. So remember, the base on the logarithm is going to be the base on your exponent situation. So you're thinking 8 to what power gives you that answer 64? 8 to the second power equals 64. So this is what we call rewriting it from logarithmic form to exponential form. Number 2, what's my exponential form going to be over here? 5 to the third power equals 125. How about number 3? 4 to the fifth equals 1024. Pretty easy, right? Just rearranging things. It's actually pretty cool because you could take this 64 and mess with it, kind of like we did on the last section where we wanted to have a certain type of base. Now, if you know that this is log base 8, that'd be cool if this 64 could be rewritten as base 8. I know this is not even part of the lesson right here, but I do want to talk about it. Log base 8, if I could change that 64 to become 8 to a certain power, which I could, what's 64 in terms of 8? 8 squared. Now, remember I said when you have log base something of that same something, it cancels out? Check it out. Right here, it would cancel out, and the answer is 2. That's why the answer over here is 2. So I just wanted to show you how you can manipulate even numbers inside logarithms to be able to get those answers. But right now we're not practicing that. Right now we're just practicing rearranging from logarithmic form to exponential form and vice versa. So number 4, let's rewrite that in exponential form. What's that? 13 to the third equals 2,197. Number 5, what's the answer there? 2 to the fourth equals 16. Number 6, what's the answer there? 9 squared equals 81. The next one? 3 to the 1 power equals 3. Number 8? 7 to the 1 power equals 7. Bless you. Number 9? B to the x power equals y. And this is what we wanted you to memorize in the first place. Right there. That's what we wanted you to memorize in the first place. The rearrangement. Okay? Let's look at this part down here. Now, down here it gets more fun because we actually have to think now. What's the answer to number 1? 2. Now, if I asked you why is the answer 2, that's where you would say because this base, that 2, to what power gives me 4? Because 2 to the second power gives me 4. That's why the answer is 2. So rewriting it in exponential form is not only good to be able to rewrite in exponential form, but also to justify an answer. So like you're going to tell me the answer to number 2 is what?
4.
Yeah, you're telling me the answer to number 2 is 4?
Yeah.
Why? Because 2 to the fourth power equals 16. See what I'm saying? Okay. How about number 3? What's the answer to number 3? 3. Why is the answer 3?
Because 5 to the third power equals 125.
That's right, because 5 to the third power equals 125. How about number 4? What's the answer there? 2. Why? Because 9 squared equals 81. What's the answer to number 5? 3. Why? Because 4 to the third power equals 64. Perfect. Whoa. There we go. Number 6. 1. Why? Because 3 to the 1 equals 3. Or you could remember this. Log base happy face of happy face. It eliminates. It becomes 1. Right? Number 7. That one's interesting.
0.
Yes. 0. Why 0? Because 7 to the 0 power equals 1. That's right. Anything to the 0 power equals 1. Perfect. Okay, how about number 8?
1. I know it's 2.
It is 2. Why is that? Because 7 to the 2nd power will give me the answer 49. Right? Number 9? 1. Number 10? 0. Number 11? 1. Number 12? The heck do we do there? I don't know. All right, we can't even do this on the calculator. Calculator doesn't do base 5. It does base 10. So we're kind of stuck here, right? Unless we start manipulating things. Like that 0.2 is throwing me off. I'd rather have a fraction. Let's change that 2/10 into a fraction. What would the 2/10 be? It would technically be 2/10, right? 2 over 10, which reduces down to 1/5. Okay, so what we really have here, guys, is log base 5 of 2/10, which reduces down to 1/5. Now we could think the base 5 to what power will give me this answer 1/5? Yeah, -1 right here. That would make this whole thing move down, and the 5 would be on the bottom. So your answer, number 12, is -1. So that one did require some thought. I like it. How about number 13? What does this decimal become as a fraction? 1/4, right? Yes, that'll be the answer. But let's the 0.25, we're going to change it to 25 hundredths, and 25 hundredths reduces down to 1/4. So what we really have here is log base 2 of 1/4. Now, since this is a base 2, wouldn't it be nice to make this a base 2? Right? So how could we change 4 to become 2 to a certain power? 2 to what? 2nd. So you really have log base 2 of 1 over 2 squared instead of 4. And then you could take that 2 squared and move it up. That way you'll get log base 2 of 2 to the -2 power. And then you could say log base 2 of 2 eliminates, and your answer is -2. That's one way of doing it, manipulating. Or the other way would be to think this base, the 2 to what power will give me the answer 1/4. Oh, that's a -2 right there, because that would move it down and it would make it 1 over 4. So either way is good, whether you want to manipulate the base or whether you want to just think what value could I plug in right here, and that would move it down to make it a 1/4. Either way, you get the answer -2. 14. And why? How do we start this out?
Do log base 1 over 3, which would be equal to, you can put it in -1, which you would have to find out what can give you that. You can put it underneath, make it negative.
So if I wanted to write an exponent, how about this? In exponential form, what would that look like? The base 1/3 to what power gives me 9, right? That's exponential form right there. So what do you say? What number right here would end up in here, which would cause it to move up to become 9? Negative what? -2. So the answer is -2. Samantha, what do you think? All right. So number 15, what's the answer there going to be? -3. Because 1/5 to what power will give me the answer 125? That will be a -3. That would cause it to have a -3 right here, then flip up, and it would become 125. How about number 16? That one's interesting.
0.5.
0.5. Where do we get that from? My brains. 64 to what power will give you 8? What is the power of 1/2 really? Square rooting, right? So a power of 1/2 is a square root. So if I did have the 1/2 right there, I'd do the square root of 64, which would give me this 8 right here. So yes, the answer is 1/2. How about number 17? 1/2 also, because 4 to what power will give you a 2? The square root of 4 gives you 2. So yeah, 1/2 belongs right in there. How about number 18? What's the answer there? 2. Why? Because the common log, 10 to what power gives you 100? That'd be a 2 right there. So the answer is 2. How about the last one right there, 19? 1. That's right. Log base 10 of 10. Log base happy face of happy face eliminates. It becomes 1. Number 20. ln. What is that ln? It's natural log, which really means log base e of e. What's the answer? 1. Log base happy face of happy face is 1. It eliminates. Now for the really fun stuff. Yes, even funner. Log base 13 of 13, what happens? 1. You know what? I might as well explain this now. Just like log base happy face of happy face cancels out and becomes 1. If you have 13 to the power of log base 13 of any item, let's say 7, the 13 to the power of log base 13, that also eliminates, and your answer just becomes 7. You guys understand that?
Yeah.
Okay. So we're going to have to apply that here. Number 2, log base 5 of 5. What's the answer? The answer is just x. It comes down, no longer an exponent. It comes down, it's just x. How about number 3? The answer is x. 3 to the power of log base 3. That's like saying the happy face to the power of log base happy. Well, I can't. That's horrible. All right. 3 to the log base 3. That eliminates. The x comes down. That's your answer. Number 4. What's the answer there? 4. Why? Because it's really 10 to the log base 10 of 4, and 10 to the log base 10 eliminates, and the answer just comes down, it's 4. Got that, Ariana? Ariana, what's the answer number 5? That's log base e of e to the 2x power. So the answer is 2x. Log base e of e is just 2x. To the power of 2x comes down and it's just 2x. How about e to the log base e of 7? 7. How about number 7? 7x. You got a common log of that same base, log base happy face of happy face. The 7x comes down. That's your answer. Number 8. Could I eliminate this log base 3 and the 9? Not yet, because in order for me to be able to do that, I need the same base to be there, right? I need log base happy face of happy face, and right here I have 2 different numbers. So let's do this. Let's manipulate the 9. If I want that base 3, let's change that 9 to be 3 to a certain power. What's that going to be? 3 to the second power is 9, right? And you still have the power of x. Power to a power you multiply, and log base 3 of 3 eliminates, so 2x is your answer right there. Braulio, you got that? Braulio, help me out here. What do I need this 16 to be? 4 to what power? That's right. So what's your final answer going to be, Braulio?
Log 2 base of 4.
Bless him.
4 to the second power equals 5x.
So what's the final answer?
The final answer should be 5x.
10x.
10x? Oh, yeah.
Why? Because, see, the whole purpose of changing this 16 to become a 4 is so that you could take this log base 4 of 4 and eliminate it, right? And then a power to a power you multiply, that's 10x. Okay? It gets more fun. What's the answer there going to be? 2x. Because a 25 becomes 5 squared, so you have log base 5 of 5 squared to the x power. Log base 5 of 5 eliminate. 2 times x is 2x. Answer there?
That's
6. 22 to the power of log base 22 eliminates. Answer comes down to 6. Number 12. How much? 16? What kind of base do we want? A 3. So we're going to change that 81 to become base 3. So that's 3 to what power? There you go. So you really have log base 3 of 3 to the 4th to the 4x power. Power to a power you multiply. And log base 3 of 3 eliminates. So yes, your answer is 16x. Bless you. I mean, you coughed. You didn't even sneeze. I take that back. No, still.
No, God bless.
May God bless your soul. 13. 6x.
Yes, sir.
How?
We have to get the base of 2.
You have to get the base 2 because you have a base 2 on the log. So you're going to have log base 2. The 64 becomes 2 to the 6th to the x. Multiply power to a power. Cancel log base 2 of 2. You end up with 6x as your final answer. Last question right here.
Negative 3x.
-3x. Good. Now you guys are catching this good. You see, this base 2, you got to change that 8 to become base 2. So when you do that, you're going to have 1 over 2 to the 3rd. And of course, you don't want a fraction, so you're going to take this and move it up. That way, you end up with log base 2 of 2 to the -3, and it still has this outside exponent of x. So yeah, power to a power you multiply. That's -3x, and log base 2 of 2 eliminate. So that -3x comes down as your answer. No more exponent. And that's about it, guys. That's technically half of the lesson. I actually broke this one section into 2 halves. The first half is dealing with the algebra part. And on Tuesday, when we get back from the 3-day weekend, we're going to be graphing logarithmic functions. Now, on this worksheet, it tells you, like, this first part is similar to questions 13 through 18. The second part's similar to questions 25 through 36. And this last part's questions 19 through 24. And this is all from the book. So you could get a book right now, and you could work on it. On this video, I'll show you the teacher edition of it, so you guys could go through the answers. So on this video, you could watch the video, hit pause on whatever answers you need to check, or hit pause to copy them down. But you're going to need all these questions. And we're stopping on 36 because the next part is graphing, and we're going to hold off on graphing till Tuesday. I'm done. You're not. Feel free to grab a book and get started.